today is going to be on the properties of the parallelogram. We're going to start off by talking about the definition of the parallelogram, and we see that first off right here. If we think about the word parallelogram, it brings us to that first property which comes from the definition, and that is that the opposite sides are parallel. And that's really important because when we know that our sides are parallel, that allows us to apply all of the different parallel line properties that we learned about back in Unit 3. Okay, so that's the definition, and that's where we get our first property from. We also have other properties of the parallelogram. So for each of the properties, we're going to write the equation that represents the property in the diagram. Okay, so opposite sides are congruent. So opposite means that those are going to be the sides across from. We're talking about the side lengths, not the angle measures, and we want them to be congruent. So if I look at my diagram, here's the side, here's the opposite side. If I'm talking about opposite sides being congruent, the equation I would write would be 5x plus 10 is equal to 64. Now a parallelogram has 4 sides, so not only, let's not use the word or, it's and, the other set of opposite sides are also going to be congruent. So I would also say that 18 is equal to 2y minus 12. So to show the opposite side congruent property, we are setting the opposite sides equal to each other. Number 2, we've changed from opposite. Now our keyword here is consecutive. So angles next to each other. Consecutive angles are supplementary. Remember, supplementary means that they add to 180. This is an application of the parallel line property. So if the top line, opposite sides are parallel. If those are parallel, that means that this is a transversal, making these same side interior angles. And I can do that same thing around the entire diagram. So one equation I could set up, consecutive. So 130, if I'm looking at 130, consecutive means the angle next to it. Down here, this angle is next to it, but I don't know what that angle is. This angle right here is also next to it. So consecutive angle supplementary, I would do 130 plus 3p plus 15 is equal to 180. That's how I show that same side interior relationship. If I had instead picked this angle to start with, yes, this angle is consecutive to 130, but we already did that equation. I could also use this one. I can use that same relationship around the entire parallelogram. So it's any two angles next to each other, not across from, but next to. So another relationship that I could have written, 3p plus 15, that's that first angle, plus 8z minus 22 equals 180, and that's also that same side interior angle relationship. There are 4 different equations if I had all 4 angles. These two, these two, these two, these two. Any 2 angles next to each other are going to add up to 180. The next property, now we're back to that opposite relationship. So angles that are across from each other are congruent. Across from. So 130 is across from 8z minus 22. And we've changed from supplementary to congruent. So I say 130 is congruent or equal to 8z minus 22. I don't have the other angle measure, but I also know that this angle is congruent to that angle. Opposite angles are congruent. Both sets of opposite angles are congruent. The last property here is that the diagonals of the parallelogram bisect. Remember what bisect means? Bisect means it's going to cut into 2 equal pieces. So this is a diagonal, and this is a diagonal. The diagonals are connecting the vertices of the opposite sides of the parallelogram. So it's going to bisect, cut that diagonal into two congruent pieces. It also cuts this diagonal into two different congruent pieces. So that would be 7x plus 4 is equal to 3x plus 36. All right, so we're going to set up those equations to represent how I would work with that property. So we're just going to look at these same things all on one diagram. So the definition, that's what we started with. It is a quadrilateral, that means 4 sides, with opposite sides parallel. The way I would draw this on my diagram, parallel is arrows. The definition, that gives us our first property. From there we get more properties. The second property is opposite sides are congruent. So the top is congruent to the bottom, the left is congruent to the right. Another property is opposite angles are congruent. So we know opposite are congruent. Opposite sides are congruent. Opposite angles are congruent. Opposite, the key is that it's things that are across from. Number 4, consecutive angles are supplementary. So this is the one that we can't really mark on our diagram because it's the relationship of adding and setting equal to 180. So one example would be the measure of angle R plus the measure of angle A is 180. Any two angles that are next to each other are going to add up to 180. And then our last one, diagonals bisect each other. So we've got to draw our diagonals in, connecting across from. We've already used those indicators, so this one is congruent to this one is congruent to that one. Okay, so those are, just making sure that's up, yep. That is, ooh, sorry about that. That was putting all of our parallelogram properties all on one diagram so you can see how they relate to each other. All right, that is it for the video.